All right, finishing up chapter 11 with section 11.8, surface area and volume of spheres. We're going to combine spheres into one day, surface area and volume. They're basically, you just have to know the formula and how to plug in the answers. Surface area is 4 pi r squared, and the radius is from the center of the sphere to the edge. And volume is 4/3. But this time pi r cubed, 4/3 pi r cubed for the volume. How does that work? Here's a sphere with a radius of 7 feet. Find the surface area of the sphere. We're going to do surface area equals 4 pi r squared. And again, you're going to write down and show me what you put in your calculator, which equals 4 times pi, the radius is 7 squared. Exact answer to that, you're going to take 4 times 7 squared and get 196 pi, and then that is square feet. What is the approximate answer to that? You're going to multiply that times pi and get 615.8 square feet. 4 pi r squared. Piece of cake. Or should I say piece of pie? Huh. Find the volume of the sphere. You can draw a sphere if you want to. You don't really have to. They did give us the diameter. That doesn't do us a lot of good. Finding the radius is more of what we want. Before we did the surface area, now we're doing the volume, which is 4/3 pi r cubed. Volume equals 4/3 pi r cubed. What does that look like? 4/3 times pi times 6 cubed. Exact answer. 6 cubed is 216. But if you take that times 4/3, it's 288. So your exact answer is 288 pi cubic feet. Multiply that out for a rounded answer, 904.8 for the approximate volume of that sphere. But then we'll get just a little bit more creative and not just have a nice little round ball to work with. We need surface area and volume of this canister, or maybe if it's really huge, it's a silo. I don't think silos are only 16 feet. Some kind of building, maybe. The height goes from here all the way to the top. They're giving us the height. And the radius that they're giving us is 5. So the radius, whether you're working with the cylinder or if you're working with the sphere, the radius is 5 on both of them. The height, we have a little bit more work to do. The height is 16 from top to bottom. If we're looking for the surface area of the cylinder, we need to do 2 of the bases, so 2 pi r squared, plus pi dh. 2 of the bases plus pi dh. That's for the cylinder. For the sphere, the surface area is 4 pi r squared. But let's be careful here with our formulas. This cylinder has a top on it, meaning if we are looking for surface area, there is no top of the cylinder exposed. The top of the cylinder is a sphere. So we don't want both this sphere or that circle and that circle. We only need one of those. And in looking at the surface area of the sphere, it's not a sphere. There's only half of a sphere there. So instead of 4 pi r squared, we're going to divide that by 2, or just call it 2 pi r squared. Instead of 4 pi r squared. So we got to really think. We can't just slap out some formulas and do it. So let's take a look at surface area of the cylinder. Pi times 5 squared plus pi times 10. We still need the height of the cylinder. Shoot, we didn't find the height of the cylinder yet. But this is a radius. If this is a radius, this is a radius no matter where you draw it. Which basically means this distance is 5 from here to here. What's left for the height of our cylinder compared to our entire figure? The entire figure was 16. So the height of our cylinder is 11. No rounding. Let's shorten this up. Pi times 5 squared plus pi times 10 times 11. You're going to take 5 squared plus 10 times 11. 5 squared plus 10 times 11. We can combine like terms because they're both pi. We have equal to 135 pi for just the cylinder without the top. Surface area of the sphere, we want 2 pi times radius squared. 5 squared is 25 times 2 is 50 pi. All together, let's go purple since blue and red make purple. See what I did there? The surface area is 135 pi for the cylinder plus 55 pi for half of the sphere for a total of 185 pi. Want an approximate answer to that too? 185 times pi is 581.2. And I believe that was measured in feet. Okay, now just think for a second with me. I said, oh, that's a big canister or cylinder, or is it a silo? This isn't a real life problem, but it could be. And if this were a real life problem, and this was a silo, and it was sitting on the ground, would you use the base as a surface area? If I said, I'm going to paint this silo, I'm going to cover the silo in whatever, paint, in cement, in bricks, whatever I make it out of, is the base a surface? It's not. So we would get rid of both bases. But in this case, it wasn't a real life problem. It's just a picture, just a figure. You have to get the base down here. You take out the base on the top because it's not really on the surface. And you think through it logically. Okay, done with the problem. No, we still have to do volume. Volume, capital B times H, which we always just go to pi r squared H. For a cylinder, volume of that cylinder is pi times 5 squared times the height of our cylinder is 11. And if I take 5 squared times 11, it's 275 pi. We don't have to worry about does it have a top, does it have a bottom, because if you're going to fill this cylinder up, you're still going to fill it from bottom all the way to the top. And then we're going to fill the sphere. If we go all the way to the brim, the sphere is 4/3 pi r cubed. But again, it's not a full sphere. It's only half of a sphere. So let's go with 4/3 pi times 5 squared divided by 2. Or of course, we could have used 2/3 right there. 4/3 cut in half is 2/3. If I take 4/3 times 5 squared times or divided by 2, I get, as a fraction, work on fractions here, 50 pi over 3, or 50/3 pi. That's kind of a mess to add these two together. I mean, you could. 275 plus 50/3 pi. But if I just go with an approximate answer, about how big is that volume? 275 pi plus 50 over 3 pi, you would get 916.3 cubic feet. All right. Good luck with your surface in your area. Make sure you use the pieces that you need for cylinders or spheres, whatever it is, and watch your labels. Square feet compared to cubic feet. Good luck.